So yes, we're going to continue. So I'll give you an introduction in a minute. So it's my pleasure to introduce Dr. André Galli to give today's talk about planetary protection amidst this COVID-19 pandemic. He got his PhD in space physics at the University of Bern in Switzerland in 2008. And since then, he has spent his time mostly with scientific research in the Netherlands Institute for Space Research and at the University of Bern. His interests are centered on the terrestrial planets like the moon, icy moons, as well as comets and the solar wind. He is currently involved in NASA's heliospheric missions IBEX and IMAP and ESA's JUICE mission to the icy moon of Jupiter. So take it away, André.
Thanks for inviting me. Thanks for listening to me, and welcome everybody. Here it's evening, at your place it's morning or, well, before noon. This is, I think, the second talk in a series about planetary protection, what questions pop up if we talk about space exploration. So going from Earth to other celestial bodies out there. So going to the moon, going to the Mars, and what you need to think about when you do that. So I titled today's talk Planetary Protection, which you already heard about, and Planetary Sustainability. I will evenly split my talk into those two things. They are related to each other, but they are not identical. So since you're already a bit familiar with it, I'd suggest let's start with planetary protection, just to bring us on the same page, and then from then on head forward to planetary sustainability. Next slide, please. So we return to planetary protection once more. What does it mean? And what does it specifically mean for some planets you want to visit, or for some space missions? What does it actually mean? Then I will inject, I'd say, one single slide about space law. This in itself would be interesting enough for a whole series of talks, but I will have to constrain myself to just one slide, but it's very important. And then, as promised, we will get to planetary sustainability. What does it mean? And what does it mean for space exploration? Next slide, please. So, planetary protection, what is it? I assume, and yeah, I hope that you all know that, well, planetary protection is not actually standing with a sword next to a planet and fencing off some asteroids that want to crash into the planet. But what else could it be? So if we ask the internet, what other memes do we find? Next slide, please. So we have a somewhat more realistic image here about probably the sterilization of a spacecraft. And we have some other pop cultural references to the Man in Black. So protecting a planet from the worst scum in the universe, which might be our microbes. And then, of course, then also children that want to be the next planetary protection officer. Next slide, please. So you've heard the two basic rules of planetary protection. Rule 1, don't contaminate other celestial bodies. Don't bring our microbes to other places, like Mars. This is followed by rule number 2. Next slide, please. Don't bring back extraterrestrial organisms back to Earth, so-called back contamination. Of course, we don't know. Can you go one slide back, please? Of course, we don't know if there are extraterrestrial organisms such as, I don't know, Martian microbes or a virus from Venus. We we never found such a thing yet, but we just want to make really sure that we don't bring such, well, such microbes or viruses, if they exist, back to Earth. For reasons that should now really be very obvious to everybody living on Earth right now. So next slide, please. Just a brief look back at the history of planetary protection. What's astonishing is how early scientists realized that this is important. If we go back in time, the space age began basically in 1957 with a Soviet spacecraft, or I would say probe, a Sputnik 1. That was the very first man-made spacecraft ever launched into orbit. So this year is as good as any year to stand in as the beginning of the space age. Next slide, please. And only one single year later, the goals of planetary protection were already formulated. So some physicists, some space scientists gathered and had the idea that, well, if we go out to outer space and want to visit other planets, moons, we should be careful. And the basic idea back then was actually not so much that they were worried about wrecking an extraterrestrial ecosystem, but it was rather, you could say, simplistic, or, well, it was from a science point of view. Those scientists were worried that we want to study other worlds if there's any life out there. And scientists were worried that if we bring our own microbes to those places, then we will just find again our microbes from Earth. Maybe we will kill other microbes that had been living there on the moon or on Mars. But in any case, the search for life, the study of life, will get very, very difficult if you bring your instrument on Mars, let's say, and you want to see, is there any Martian microbe living on my Martian soil? And then you find something that sort of, you find a microbe, and then it takes you years only to find out that it's just something that you brought from Earth. So originally, that was the basic idea. We should not endanger scientific study of life on other planets by being careless with bringing our own microbes to other moons and planets. And of course, the other thing, the back contamination, was on people's mind already back then. They said, yes, we must be careful in case there is life out there, not to bring it back to Earth, where it might wreak havoc. So 1 year after the space age began, the idea came up, and already 2 years after, so 1959, there was a new scientific committee on space research, COSPAR. It still exists today. It's a big thing. There are biannual conferences, and this committee of researchers is maintaining the planetary protection rules. Another big year came in 1967. This was and is very important even today when you talk about rules in space and about space law, because in 1967 the Outer Space Treaty was signed, and there in Article 9 you have it it's stated explicitly that harmful contamination of celestial bodies must be avoided by any spacefaring nation. So that was a big step. And the good thing about this and about the Outer Space Treaty is that by now most countries in the world have signed and ratified this space treaty. So it's legally binding. If you go to outer space, you have to stick to those rules. And then of course, planetary protection the history went on, we learned more and more about other planets and moons, and from time to time the rules were updated because we found out basically when we learned that there are salty oceans of water underneath the ice layer of Enceladus and Europa and probably of other icy moons in our solar system, it was clear, all right, these oceans are a place where life as we know it could exist. So they are a high-level category of places that must be protected from microbes from Earth. So the rules were updated. And the latest update came recently, just 3 years ago, when, again, this Committee on Space Research made an update and then also warned space agencies such as NASA or the European Space Agencies, folks, listen, we learned again new stuff. So this is how the Planetary Protection Rules have to be updated. But the main goal remains, we must avoid organic constituent and biological contamination in space exploration. And at this slide, we'll take the opportunity for a quiz. We'll just see if this works to enhance the interaction between me sitting here in Switzerland and you sitting in the United States. Let's do some simple surveys to test your knowledge about space science, but also about history in this case, because we're talking about history. So on this slide, you see some politicians in the 60s sitting there at the table. And my question to you would be, do you know the man sitting to the right edge of the photograph? Do you know that face? So next slide, please. So that would be the first vote. It's rather about history than about space science. Do you know that guy? And now I'll activate the survey. Wait, I'll just have to log in. And all right, now please try to type in on your smartphone or your laptop the link that you see there, and then you have to press a button. Actually, I don't know if it's in German or in English, but anyway, just press. There is basically just one button that you can check, and then you should see a multiple choice option with 4 different names of who that politician might be, sitting to the right.
I will interject here that it is in German, but we'll do our best.
Yeah. So yeah, so it's also a simple test about your German skills. Sorry about that. And once you made your pick, there are 4 possible answers. You basically have just to go to the big red button, as the Antwort senden, which means send answer, and then I should see the result. Ah, yeah, it's working great. Great. So far we have 6 answers. And at one point, I will close the poll, and then we can see who was right and who was wrong. 10 more seconds to give an answer, and then I'll close the poll. All right, I'll close it. And yes, so the majority actually was right. So we had seven answers, and 3 of them voted B, Lyndon B. Johnson, and that's the correct answer. So that was back then the President of the United States. Nikita Khrushchev is not on this picture, if I'm not mistaken, and also back in 1967, he wasn't the leader of the Soviet Union anymore. That would have been then already Brezhnev, if I'm not mistaken. So, but so far so good. That was our first quiz. The other 4 surveys will be closer related to space science. So I'd suggest let's go on to the next slide. As I said, the Outer Space Treaty, and thus the idea of planetary protection, is now really widely, or you might say even universally accepted on Earth. Here you see a world map, and green and yellow are all the countries that have either signed or ratified the Outer Space Treaty. And you see basically every major country. You have the US, you have Russia, you have China, you have most European countries, you have Australia, Brazil, basically all important countries in terms of also of space exploration have signed and thus accepted the Outer Space Treaty, and thus accept the idea of planetary protection. This is very, very important. So I would say the strong point of planetary protection is that it's universally accepted and it's legally binding. The weak point maybe of planetary protection is that it does not, it's very limited in scope. It just says no biological contamination between different celestial bodies. That's basically it in a nutshell. So there are, in the second half of my talk, I will show that there are some problems in space exploration that are now waiting for us that are beyond the scope of planetary protection. So there we might need more than just planetary protection. Next slide, please. So probably you've already heard about this, but that's actually our second survey, and really also maybe funnier for you than the first survey. The idea of planetary protection is that depending on the likelihood that terrestrial organisms can survive on the object, you must rank them in different categories. So you basically rank different planetary objects in 4 categories, going from 1, which is basically, yeah, you needn't worry at all. Nothing from Earth can survive there, to a higher level or level of protection, which is be very, very careful if you bring a satellite there. Be very, very careful not to bring microbes from Earth. And here you see 6 different planetary objects. I don't tell you their name because that's part of the survey. And can you actually rank them into 4 different groups of objects where you needn't worry at all about planetary protection? To number 4, you should be very, very careful about bringing Earth microbe to that place. And for this, I have to activate the next survey, so please bear with me. So I activated it. So you have to again go to the same link that you also see on the screen, and then you probably have to at least in my case it works. You have to look for a new survey that should be active right now. All right, I get the first answers. That's great. Mm-hmm. Yeah, and yeah, as I said, there's a hint. The picture number F. This is probably Bruce Willis standing on an asteroid. Yeah, you know that movie. I think it's from 1998, Armageddon, where they have to, and of course it's scientific. Of course it's completely inaccurate, but it's yeah, it can be funny in a scientifically inaccurate way. But all right, so I think yeah, we have 6 answers. So I will stop in 10 seconds. All right, here goes nothing. Rien ne va plus. So most people chose D. And now we do this, everybody now has to correct his or her own solution. Let's go to the next slide where you see the right answer. So to the right, you see color-coded and with the letters where those different groups, where those different objects belong to. Basically, the idea is as follows. Asteroids and Io, so places where you don't expect any life from Earth to, well, survive, and you're not interested in those objects to study the, how to say, life or the precursors of life, you group them in the so-called category 1. So there you don't really care about planetary protection. Then you have objects B and D, so that would be, for instance, Venus and Earth, Moon, where it's quite unlikely that life from Earth can survive there. You can bring it there, but it will probably get killed. So that's the next category. Then you have an intermediate category of usually icy satellites, where there is a remote potential for contamination of the liquid water environments. So that would be Ganymede, Titan, Triton, Pluto, and actually that was letter E on the slide before. That was Pluto, so it would belong here. They belong to this category. And then we have the interesting, but thus also the endangered places. And those are, so far, it's just 3 objects in the solar system that we consider as high risk in terms of planetary protection. That's Mars, Europa, and Enceladus. Maybe Others will also follow, but so far these are the three objects where we really must be careful. And then you see the planetary protection category. That's this Roman numeral to the right. It depends on the object that you're visiting, but it also depends on the type of mission that you want to do. A flyby or an orbiter around Mars has a lower level and thus fewer requirements in planetary protection than if you want to land on the object or even grab for instance dig a hole and then check the soil for life forms. This will be a category 4, which means you really have to be careful. And then you have category 5. This is if you bring back any samples. And of course, there is the basic difference again between Mars, Europa, and Enceladus, which are considered high risk compared to any other object. So next slide, please. So I'll just try to summarize what does this mean specifically for space exploration. If you want to go to Mars, for instance, which we have seen is a high-risk planet, it means that if you want to land on Mars, and in particular if you have a sensitive lander mission, which sensitive means you want to detect life forms. It means you have very strict requirements and you have sterilization procedures to kill most of the microbes that you might carry from Earth to Mars. And of course, it might mean that you have to irradiate the whole spacecraft with UV light or with energetic particles. It might mean that you have to heat the spacecraft at several hundreds of Fahrenheit for more than 1 day to make sure that you kill most of your microbes. And of course, some of those procedures you cannot do to your spacecraft because otherwise you'll simply destroy the spacecraft. So you must think ahead of how you can meet the planetary protection requirements. Next slide, please. And if you go to Mars, there are so-called special regions. They include so-called gullies. They are not related to me, even though they sound similar. Gullies are those channels that you see on the image here. They are channels that look as if some water is trickling down from a plateau into a valley. And about those special regions, it is stated that neither robotic systems nor human activities should contaminate those special regions. We just don't know what's happening there, and if we think that there might be running water, so we have a subsurface, you have running water, so it's not impossible that life as we know it could exist there, or that microbes from Earth could actually survive. And yeah, someone is asking if there's a Mars rat. We don't know. Some people think it's water that's trickling down, that's creating those gullies. Some other researchers recently came up with another explanation that it's actually freezing and thawing CO2 ice, so basically dry ice, that is creating those gullies so that you don't need actually water to create them. But that's an open question. We don't know. So next slide, please. Yeah. Yeah, I'll come back to the Fahrenheit later. About now, if you want to send humans to Mars, of course, this is even more difficult from a planetary protection standpoint, because the rules state that your goals should not be relaxed to accommodate a human mission to Mars. Rather, they become even more directly relevant to such missions. So it means if you go to Mars, So you have humans on board that you want to bring to Mars. You have to be able to quarantine a single astronaut and also the whole crew on Mars. And then also when you come back, probably you would first have to do a quarantine on the moon if you really want to do it properly before anyone is allowed to get back to Earth. And this brings us actually to the next question. Next slide, please. Currently there's a debate among researchers about Mars exploration. So on one hand, we want to be protective and we don't want to contaminate those special regions. But here comes the debate. Some researchers think that planetary protection policies are too restrictive. So it's they're basically preventing us from doing research. This is what some people think. So some argue that if you have a meteorite impact that throws out material from Mars, it can travel to Earth and vice versa. And this is not science fiction, it happened because we have Martian meteorites on Earth. So people argue that these meteorites exchange material anyway. And another argument is that actually right now we should hurry and explore those gullies and other special regions right now, in the next few years, before any human mission. Because once you have astronauts, hiking around on Mars, we might, even though we'll do our best, we might actually contaminate Mars with our microbes, and then it might be too late to see Mars as it was before the advent of all the humans and all their microbes. So this brings us to the next survey. What do you think about Martian exploration right now? I will activate this question. So please bear with me. Yeah, so I activated it. So please again, check the link and please have your say. Here you just have two options, and it's hard to say which one is wrong or right. It's here it's rather a little bit like in politics. You can argue. Mhm. All right, I'll close the poll in 10 seconds. Your last chance. All right, we'll stop it. And here it's a clear picture. 5 out of 5 survey members think, or rather agree with, we must explore special regions now before the advent of manned missions to Mars. All right, so I'd suggest let's go on to next slide. So if we talk about planetary protection and the icy moons, there are several spacecraft or missions planned by NASA and by ESA over the next decades. And one of the, how to say, one of the consequences of planetary protection is that both Europa Clipper and JUICE have to make sure that at the end of their life, they don't crash into Europa, which is the moon that you see to the right, where we know that salty water ocean exists under the ice crust. So both spacecraft must make sure that if they crash at the end of their life somewhere, they must not crash into Europa. They are allowed, that's the case for JUICE, probably to crash onto Ganymede. That's the largest moon of Jupiter, where the contamination risk is considered much smaller. Or they will simply be steered into Jupiter and then be squashed in the atmosphere of Jupiter. Next slide, please. Yeah, and of course, it also means, planetary protection means that if you want to hunt for life on Europa, of course, currently it's impossible technically to drill through kilometers of ice on this icy moon. You have the radiation levels that you have there standing on the surface would kill any human and also fry any electronics within minutes or hours. So what you want currently, the only thing that you can hope for, next slide please, is that there are some water plumes or geysers that through which you can fly with your satellite, measure, and then be gone. But, next slide please. If you have flown through your plume, it must be very clear your spacecraft must never, ever, ever return to the Earth's biosphere or the moon, because this is a case where you could actually have picked up some real extraterrestrial microbes. Next slide, please. So, yeah, next slide, please. I'll keep this very brief. As I said, you could talk for hours about space law. I just want to state one thing. Outer space is not the Wild West. There are rules. We have met the Outer Space Treaty, but there are more rules and also more laws than just that. So, and the rules not only are meant for states or countries. This is well known that a country cannot own a part of the moon or cannot own the Mars. But it's also but it's also true, and this is not known to many people. Also, companies and individuals have their obligations by space law. So also companies have to stick to those rules, even though they are not a state or a country. A company still has their legal, they are still situated in a country, and by this they still have to adhere to laws. But of course, the question remains, what about, can you use space resources, and who enforces the laws in outer space? And these are open questions. Now, I see we started some minutes late, but we're approaching the 40 minutes mark. So I will still nevertheless try to summarize the idea of planetary sustainability, or at least point out why planetary protection might not be enough if you talk about space exploration. Next slide, please. So there are other concerns than just biological contamination if we go to outer space. So next slide, please. Everybody who is involved in space exploration agrees that space exploration, satellites, all that stuff can help us with sustainability. And of course, the first step is satellites help us with sustainability here on Earth. Next slide, please. So that's a no-brainer. For instance, without satellites, without research about the atmosphere, and also about the parts of the atmosphere that are not accessible with balloons or planes, we would never even have known about the ozone hole. We wouldn't have known about it, and we never would have been able to study it and to find ways to actually fix the problem. So this is one typical example that shows that to have a sustainable development and to care for, ecosystems and for humanity here on Earth, you also need space exploration. Next slide, please. Now talks are ongoing, and here I'm involved with some researchers and also with COSPAR. If we shouldn't set up a wider framework to get guidelines of what space exploration and space research should try to achieve. So how can space exploration help sustainable development on Earth and in outer space? And the idea is basically that we consider Earth as a planet within its outer space environment. Next slide, please. And the idea might even be that space environment is an 18th goal. So we have the 17 United Nations Sustainable Development Goals, and they are shown here. For instance, no poverty, zero hunger, and so on. And the one idea is that you could actually add space environment as an 18th goal to that. Next slide. Yeah, I'm gonna jump over the few next slides. So we're in discussion with the space exploration community, what they think. Next slide, please. And I was asking them, what do they think at an assembly? Next slide, thanks. So it came out that everybody agrees that the outer space is important for sustainable development. And with this, I come to the end of my talk. There are three main areas where researchers and space scientists are concerned about the current state of affairs. That's space debris, the moon, and near-Earth objects. Next slide, please. And one of the reasons is, of course, those are the three places that are closest to Earth. So just the orbit around Earth, the moon, and near-Earth objects, they are closest to Earth. So you have companies that want to do asteroid mining, for instance, or they want to offer, a tourist trip to the moon. So these objects are close. And the other reason why people are concerned, planetary protection imposes few or no restrictions on those objects because it is very unlikely that anything from Earth can survive there. So, and now if you just say, okay, all right, it's a free-for-all on those objects, then you might have consequences. Next slide, please. All right, I'm gonna skip over that. There are ideas for the moon village, but you really have to think how we all want to go to the moon. That will be great, but the question is, will everybody benefit from the research results, and also from cultural achievements from the moon, from those moon trips? And how will you change the lunar environment if you have a regular rockets landing there? Next slide, please. And for the near-Earth objects that people want to mine, there are companies already existing that have their business models. It will mostly be about the water-rich asteroids, because water is a very useful resource that you can bring to a moon village, for instance, or to astronauts that are in orbit, in one of those space stations. They need a lot of water, and bringing up the water from Earth is much more expensive in a few decades than probably mining the water from near-Earth asteroids. But there is one possible showstopper about asteroid mining and about also lunar exploration. Next slide, please. So I'm going to skip that. Next slide, please. Next slide, please. That's orbital debris. This is the one problem where most people agree that we already have a developing problem right now, and that this problem will get more severe over the next decades if we don't do anything. This has been predicted by scientists for at least 40 years now, that this will be a problem. And well, policies were much slower to pick up, and now we basically have a problem. You have satellites and spacecraft that, well, are out of order, they don't work anymore, and then they keep orbiting around the Earth. And of course, the low Earth orbits and the geostationary orbits are most heavily affected, because there we have the highest satellite traffic. And this is my last survey for today. Next slide, please. Question to you. How many satellites have been lost due to collisions with orbital debris? From Sputnik to this day, not counting military maneuvers, how many satellites have been lost because of collisions with a human-made space debris? And I'll just activate the poll. Please bear with me. All right, I activated it. So please, please vote. What do you think? And there's a hint on the slide. In 1978, so what is it, 42 years ago, scientists made predictions for the future, how many collisions, how many lost satellites they'd expect over the next 40 years. So you see on this plot by Kessler and Gourbet, they predicted different scenarios, and based on that, you see they predicted several satellites that actually would be destroyed by this year, by 2020, by orbital debris. So what do you think? Were they accurate? Yes, you get the first answers. 10 more seconds. All right, I'll close the poll. So most of you think that more than 10 satellites have already been lost, and a minority thinks 5 satellites have kicked the bucket. Next slide, please. So you're quite good, and also the predictions by those guys 40 years ago were actually very accurate. That was a really good paper by Kessler and Gourbet. By now, if you just account for the cases where it's very probable, or you know what had happened, then you end up with roughly 5 satellites that were seriously damaged or were completely destroyed. But of course, there might be unreported cases. For instance, there was ESA's Envisat satellite that basically communication was lost in 2012, and we don't know why. Maybe it was hit by a fragment, but who knows? And of course, this satellite now itself poses a future risk for debris, because it is still orbiting in a quite traffic heavy lane in Earth's orbit. Next slide, please. So, my summary: planetary protection is well established in space exploration. Basically, you don't want biological contamination between Earth and other celestial bodies. Space law, it exists, but there are, of course, open questions. The most important is, what can you use, or under which conditions can you use space resources, such as water from an asteroid? And then finally, about sustainability, space exploration is important for sustainable development, but we must talk about a wider framework, because we don't want to damage the very environment we want to study. And we don't want to damage the environment we need for a future sustainable development. Thanks for your attention.
Well, thank you for a wonderful talk. I really appreciate your efforts here for us. We might leave it open and let people ask questions directly, but I want to actually ask, I'm going to take organizer's privilege here, ask the first question.
Yes,
so
please go ahead.
You talked about a lot of people wanting to use ice in space as resources, and you mentioned the moon as not being very high as a planetary protection, but South Poles have ice they believe to have come from comets, which would have had organic material. So there's still a chance that there might be at least some sort of organics there on the pole. What do you think of that for planetary protection issues?
Yeah, as you mentioned, the moon is, I'd say, it's in category 2, so it's not a complete free for all. There are, I read the rules again. If you go to the moon, you have to at least document what you're doing. So you have to document how do you treat the spacecraft, and if you have such an idea as, bringing tardigrades to the moon, this actually happened with the Israeli rocket that wanted to land on the moon. You must carefully document what you're doing. Some people argue this is too restrictive. Some people say that's not enough, because you're right, there are some permanently shadowed craters on the moon where you have water ice. It's really hard to say. Probably, if you want to do it properly, you should say, okay, we must define some special regions also on the moon that are relevant for biological contamination. So the permanently shadowed craters with ice would belong to that. And there are some other special regions that might be of special interest for cultural reason. For instance, people argue that the landing sites of the Apollo missions, they should be protected like a museum, or like a theme park, so that not maybe in a few decades some company comes up with the idea of, okay, let's mine for, I don't know, platinum or ilmenite exactly at that spot where, I don't know, Apollo 11 landed. But those ideas are still being discussed. But I think, yeah, you're right with those icy craters in the permanently shadowed areas. The current protocols must be updated before you bring humans to those places.
Okay. Does anybody else want to ask some questions? can either put it in the chat or you can try and go live. I think we've got a small enough group if you want to ask personally. Just activate your video and activate your microphone. They're all too shy today.
Yeah. Just reading. Just reading the chat about the temperatures for sterilization. It's one option that you simply bake out the spacecraft, and it's really cold that way. Bake out the spacecraft at a high temperature. What you use is more than those 165 Fahrenheit you use for a hamburger. You use rather 250 Fahrenheit or something like that for 1 day. Or in degrees Celsius, it's 120, 130 degrees Celsius to kill most microbes. Okay, the newest question is, the donut-shaped space station is doable. So you mean a donut that's maybe rotating to create sort of an artificial gravity?
Yeah, I think that's what they're referring to as artificial gravity through a rotating system.
Oh yeah, there it is. Sorry. It's, how to say, this idea has been around for decades because a lack of gravity over a longer period of time is very detrimental for human health. So this is an obvious concept, and in terms of physics, certainly it's doable, and it's probably our best shot of getting at least a little bit of gravity on a space station. Of course, in that regard, it's even better to be on the moon or on Mars, because there, well, you have your gravity, or at least, well, of course, just a fraction of what you have on Earth, but there you have gravity. In terms of, I just know how to say the specific plans of what NASA and ESA plan also for the planned return to the moon mission in 2024. So for this decade, so for the 20s, such a donut-shaped space station probably is not yet, will not be out there. But in the longer run, so over several decades, I'm quite optimistic that this can be, and that this will be done. At least in terms of physics, nothing argues against it.
Okay, I think we'll have one more question. I think that's from Newton or something.
Yeah,
about the microbes in Yellowstone Park. I'm not too sure what the question is, but
yes,
there it is.
Yeah, you're right. There are microbes, so-called heat-loving. Most of them actually, I think, are archaea. So they are not bacteria. They belong to a separate domain in the realm of living things. But there are very interesting archaea microbes that can survive and even thrive at temperatures that are around 100 degrees Celsius or even somewhat higher. So, and they are very hardy organisms, where you would need to heat your spacecraft even to higher temperatures. But I think the good thing is that those organisms are rather constrained to a specific spot here in an Earth's micro ecosystem. So it's not that likely, unless you do it on purpose, that you have such heat-resistant microbes on your launch pad, or that or if you go to a lab at JPL in Pasadena, or if you go to an ESA facility, there you have some microbes, but it's unlikely that you have those very specific heat-loving archaea that are just living in the vicinity of those labs, and then just get and sort of infect the spacecraft when it is assembled in the lab nearby.
All right, thanks. I think we're going to end it here. I appreciate it. They are talking about Mars perseverance, and we hope that it will stay on schedule. They're working their best in the coronavirus. But thank you much, and I really
fingers crossed.
Appreciate all your efforts today, and we will be posting it. And so thank you very much. So if everybody gives their hands up, there's your hands up, and we'll end the meeting right now. We'll stop recording. And
thanks for listening.
Yeah, thank you. Appreciate your time.